The other way you can look at this is that R equals A plus B, which is 3I plus 1I plus 2J plus 4J. In Algebra 1, we call this adding like terms. And you get 4I plus 6J.
Are vectors always capital letters? Just wondering.
I think in this book they are. They don't have to be, no. In fact, in the pre-cal book, we'll start using lowercase letters.
Oh yeah, they are upper.
We've never taught vectors in 2 courses before. Yes?
I don't get why instead of like 3, 2, it's 3I plus 2J. Like plus, why plus?
Because what you're actually doing here, and I kind of did this and glossed over it, you guys didn't really comment on it. I told you on Friday this is a different way to write vectors. And you're writing it in terms of the horizontal vectors that are 1 unit long and the vertical vectors that are 1 unit long, right?
You're adding them up.
And what you were doing then is you're adding 3 horizontal unit vectors to 2 vertical unit vectors, and by the geometric rule, you add them tip to tail, so you start at this tip and draw your resultant to that tail. So it's just a different notation.
Okay.
But when I introduced this notation, I was sneaking in the idea of how adding vectors worked.
You sneaky person.
I am sneaky. I like to plant seeds.
By the way,
Yes?
I don't know if this
hell?
matters,
You.
but the little arrow, like the vector sign,
Uh-huh.
on the book is like a normal, like a regular.
And I only do the top?
Yeah.
Honestly, I would take twice as long if I had to draw the additional little arrow.
Oh, so it doesn't matter.
Doesn't matter. That notation's allowed. I've seen it elsewhere. Okay, so that's adding vectors. Subtracting vectors works the same way because vectors can have negative components. So, for example, I will erase over here. If I give you the vectors A equals -3, -5, and vector B equals, 5 is unclear, B equals 4, -2. What is vector A plus vector B going to be? What?
1, -7.
1, -7. Okay? You're going to have to be able to graph these as well. It won't matter which way you graph it. It won't matter if you graph A first and B first. For that matter, it doesn't matter if you start at the origin or not. You can start anywhere as long as you line them up tip to tail. Okay? Does that make sense? Okay, so adding them is fairly straightforward. One more concept. Actually, 2 more concepts. You can multiply a vector by a scalar. There was one homework question that implied this was coming up last night. There was a question on the homework that asked, what if you doubled the length of the components of the vector, right?
Yeah, and then it's like, what is the multiplicative factor? I was just like,
It was
multiplicative? It's my favorite math.
Mr. B, it sort of got me confused because it says that all the components get doubled. So
Yes.
does that mean that it gets doubled? When it's like, okay, what multiplicative factor was this times
Yeah,
by?
2.
Yeah.
So the answer is 2.
It's
And
like,
then
this is
what
a
was the
stupid question?
and then what was the multiplicative factor on the angle?
The second
1.
question was,
One.
what was
Yeah,
the
You
it was
understood
1.
it? Yeah, because you multiply it by 1.
So that was it?
Yep.
I got it right?
Yeah. All you had to write was 2. If you double the x and y components, it doubles the length of the hypotenuse of the vector, and it doesn't change the angle. You did this with different words with proportionate triangles in geometry. When you did proportional triangles in geometry, you did everything you need to do. Well, not everything you know about vectors. You did everything we've already done about vectors. Now we're starting to get into the new stuff.
Wait, can we do subtraction?
Yeah. Well, that's what I'm going to get to in a moment. You can multiply a vector by a scalar.
Wasn't vector like velocity and then scalar wasn't it
Speed. Yes. So vector is magnitude and direction. Scalar is just magnitude. So in other words, a scalar is just a number.
So how can you multiply them?
I'm glad you asked. If I have vector A is 2, 5. Okay? And I want to talk about 4 times vector A. Okay? Now last night the homework question said if you double the components of the vector, double the x and y components, you get a hypotenuse twice as long and no change in direction. You get the same angle, right? That's what everyone should have gotten for number, was that number 8? No, number 8 was different. That was, I forget what number that was.
Which one?
The one that said if you, that asked for the multiplicative factor.
That was number 1.
Number 1. Okay. I knew it was either the beginning or the end. So, basically, if I double these, I get a vector that's twice as big going in the same direction. If I triple these, I get a vector that's 3 times as big going in the same direction. It's all proportional triangles. So if I say what vector is 4 times bigger than A, all I have to do is multiply 4 by each of the components. And that vector will be the vector 8, 20. 8, 20, or 8I plus 20j is a vector 4 times as big as angle A going in the same direction. If you answered number 1 correctly last night, then you were, whether you knew it or not, multiplying a vector by a scalar.
I knew it.
Somewhere deep, deep, deep in your stuff. You better know it. You took pre-cal last year.
Right. Yeah.
It's not the one you should
It's
brag
called
about.
summer, and I forgot it already.
All right. Now, subtracting vectors.
No,
Okay.
I forgot it.
This is a little bit like the distributive property in Algebra 1. Subtracting a vector is the same as adding a negative vector. If you can multiply a vector by a scalar, you can multiply a vector by -1.
We can do algebra with vectors.
Little bit, baby algebra with vectors. You're not, you won't be. In this class, I won't get you ready for grown-up algebra with
Where
vectors.
I like
Grown
baby
up.
algebra.
vector.
Little bit, believe it or not.
Let's
Don't
just
go
stay
there.
with baby algebra.
Yeah, baby algebra's good.
Okay, so a vector A, I'll keep using the same example from over here. If vector A is 2, 5, then negative vector A is going to be -1, the scalar -1 times 2, 5, which will be, I'm going to write it as -2i minus 5j. I'm intentionally mixing and matching the notation. Okay, because I want you used to both. So you can multiply it by the scalar -1. So, Kath, you asked about subtracting vectors.
Yeah.
If, new example, if vector A is 2, 5, vector B is 1, 4 again, just like those numbers, what do you think vector A minus vector B is?
1, 1.
A plus negative B.
A plus negative B is a great way to think of it. What's that going to work? Or you can just subtract the components.
Isn't it 1, 1?
Yeah, that's going to be 1, 1. Again, you got to be able to draw these, and there won't be any one right answer when you draw them, because you can literally start them anywhere. Okay, it won't matter where on the Cartesian coordinate plane you draw them. It's easiest for me to start at the origin. Makes graphing the final point simpler. But, you know, if you want to start graphing at 50, -50, go crazy. It will not be mathematically wrong. Now, I want to do number 8 real quick, because that may be important for some of the homework tonight, and I saw some people struggled with it. It's not about adding or subtracting vectors, but let's see. I last did this. I'm going to move, get rid of this now. Okay.